Hello, my name is Graham Rollins of Engineering CAD Solutions. Today we are going to look at a video of possible ways of capturing concrete beams in a bridge design. So we have the point cloud loaded here in TopoDOT. This particular point cloud had 8 different scan positions, and these scan positions were captured below the bridge surface. So it's captured the bottom of each of the concrete beams. So I'm going to show you a few different ways or methods of capturing these concrete beams. So we'll just spin this view around. See there are 4 spans of concrete beams across these individual piers. And so the 3 different scenarios of what I'm about to show you, we've currently got our piers and pier caps. The first one will be individual segments of concrete beams which run between each of the separate piers. And these will be just simply extruded profiles. The second method will be to extrude a profile along a trace curve that runs the full length of the bridge. And the third will be a similar result, but using the template tools as opposed to the draping tools. Right, so let's begin. I'm going to spin that view back around to the top. I'm going to put it back into wireframe mode. And I'm going to turn on my point cloud. So we can see it there. Okay, so the first one we want to do is create straight extruded segments between each of the piers. And so we'll take a cross section at the beginning of the bridge. And here we can see the cross section of those concrete shapes. Now, beforehand, I've gone ahead and created a cell library, and I've created a concrete beam profile cell, which is symmetrical, and will fit each of these data. So I've cut a cross section through the beginning here. What I'm going to do is just go in and place a number of these beams. And I'll switch on the level so you can see it. And we're going to line up the cells so that they sit perfectly over top of the concrete beams at this section. Okay, I'm going to do 4. There's one from an earlier exercise. Let's just get rid of that. So you can see here we've got the 4 cells being placed at this end. So we'll now go ahead and create a cross section through where these beams meet the pier. Just go through that section there. We can see these concrete beams again. And I'm just going to go ahead and place another set of these 4 over the first pier over the road. Okay, so currently now what we've got is perfectly aligned profiles sitting over each of those end spans. So we'll put the cloud off and we'll spin this around. Now we can see the profiles at the beginning and the end. So we'll just draw some profile lines, some trace lines that go through between each of these, knowing full well at the ends they are perfectly lined up with the cloud. Okay, so this process may or may not suit you, depending on what kind of outcomes you're looking for. So I'm just going to drop these cells. I'll just drop them into individual shapes. And then I'm going to grab onto the Solids modeling toolbox, the extrude along path. And I'm just going to pick the path and the profile, accept, path, profile, accept. Okay, so it's quick and easy. We have managed to get some concrete beams sitting there. And these are going to be perfectly aligned at the ends. So the cloud should be perfectly lined up there. All right, so what we're now concerned about is how well did this perfectly straight extrusion fit the cloud, particularly mid-span. Okay, so what we can do is we can now return that view to top. Let's go ahead and create a cross section straight through the middle of the span and review what's happened over here. We can see that even though they're perfectly lined up or aligned at the ends of the spans, we have now got some discrepancies through the middle here, and these beams are exhibiting not only a vertical arc or curvature, but there's also a slight amount of horizontal as well. Let's just pop a measurement on that. So vertically, we've got 30 millimeters out. Horizontally, we've got roughly 20 millimeters out. So with the curvature of those concrete beams, this method hasn't suited for mid-span. Okay, so what I'm going to do is I'll just go and park those on beams 1A. And then go and switch that level off in all views. There we go. All right, the second method, what I'm going to do is to place a line and drape it onto the data. So we're going to choose the Smart Line tool. I'm going to put it onto my default layer. And I'm not going to choose one of these. I'm going to go over the fourth one, 1, 2, 3, 4, and I'm going to place it. You could go straight down the middle, but you're not going to get it perfectly accurate. We want to find a better way of lining that up if we can. Okay, so in this particular case, I'm going to trace over exactly the that particular web member, and that'll get my XY alignment going as accurate as I can. AccuDraw also comes into play here. It wants to snap accurately, and this bridge is just slightly off the x-axis. So we're just going to switch off the axis lock for a second. So we've got free form to do this. The process of doing the drape, we want to drape it to the lowest point. Now, if we pick the point here, it's going to drape it to this low point on the underlying pier cap. So I'm going to place a point so that it's far enough away from that pier so that it doesn't get in the way. And I'm just going to place a pair of points on that web that is either side of the pier for the full length of this particular beam. Okay, so I want to keep away from that pier as well. All right, so I've got that position in there now. I really want it in the center so that I can get this lined up. So I'm just going to move this the line that I've drawn in the XY axis. I'm just going to move it halfway down to over here. So I'm rest it there. Okay, so halfway. And so that'll be now perfectly, hopefully, in the middle of that beam. The next step for us is to go ahead and drape this. Okay, so let's put up to this other end here. Select it and grab the draping tool. Now we've got some options here of what we want to do here. We could either choose to drape it, considering all of the points for the full width of the concrete beam, or we could just consider them just for the inner section. So we might go with this inside only and ignore all of the points on the outside of the beam, just in case the beam is slightly skewed over. So we'll go with that. We'd also want to make sure that this rectangle, search rectangle, is not going to be enough for it to accidentally get to the piers from the points that we picked. I'm going to specify an interval of 7. The spans between each of these piers is 28 meters, so we're hopefully going to get about 4 even spread off those points as we go through. So let's give this a go. We're going to get the process, and we are now into the QA/QC week. We can now evaluate how well it went. So we can see the yellow dots where it's actually draped these points to the data. Right. No wonder I couldn't find them. I forgot to turn off the rest of the cloud. All right, so before we process this, we needed to isolate all of this data here. So there's a couple of ways we can use to isolate the extra data. So we don't want all of this stuff underneath. We only want the bridge. All right, so we can do a couple. You could do this a couple of ways. I'm just going to do a section through there so that I've only got just the bridge that way. Then I'm going to do a horizontal section through here at a height of 2 meters. I'm just going to select roughly the bottom section there. And that should isolate just the section of the bridge concrete that we need. Just going to get rid of those original points. Let's try it again. So we've got our line now. We're going to go for the drape tool. We're going to stick with these values that we had before. Go process, and we've now got some better results. We've got our yellow dots going through each of there. So we can QA/QC this. We can go through each of this. You would spend considerable time just going through making sure these have landed spot on where you want them to be. Paying a lot of attention, of course, to those points above the piers. So because I've gone away from the pier, this point here has landed pretty successfully. So I'm just going to go ahead and accept that. And we've now got our drape line going through there. We should also pay attention to the ends. So I'm just going to do another section through here, 2, 3, 4. And make sure that showing all of the cross-section data through that whole beam, that we have got these last points are lined up. And I can see that one's not too bad. Let's pop out to the other end. And there's a few in here that could be adjusted. So yeah, some vertical adjustment possibly required to line those up. I'm just going to using the compass, just to line that up a little bit further along there. It should still be aligned in the center. All right. So you can tidy those up. The last step in the process again is to extrude the profile along this trace line. So we'll go ahead and cut a cross section through here to make sure that our axis is perpendicular. We should now see our profile line sitting here, and we can pop ourselves a cell, grab our concrete beam, and we'll whack it on there. Go ahead and drop it, so it turns it from a cell to a shape. Then we will extrude it along. So grab our extrude tool, pick the profile, accept. And we're going to check what the results we got. First of all, let's turn the whole cloud on. And then we will set the pivot point to be about halfway along here. Spin that around. Okay, so we're going to have a bit of a look at see how that went through there. So here we've got the arch. We've got a continuous beam that goes right from the ends of the bridge, and we can see that it is arching and following that cloud. Okay, so if I were to put any vertices in through the middle here, we've got a couple of vertices in here, you can see, because it divides off the solid extrusion that we made. So it's fitting that quite well. We'll come back in a minute and we'll check the alignment midway through those spans. Okay, so what I'm going to do is I'm going to go and park that on 2A and then go and switch that level off. In all views, there we go. Okay, so the last method, what I would like to show is using the template tools to be able to follow one of these concrete beams. So in my library, I've gone ahead and created a template. The template that I've created is just around the bottom section of the concrete beam. And what I've done is I've placed 3 trace lines through here so that the software will create me break lines as they go through and trace the cloud at the bottom of the beam. All right, so you can see there, I've got one. I'll just place one so you can see it. So there's the TopoDOT break lines that I've already built into this particular template. Okay, so what we'll do is we'll come back to our main view. We go into top view. Might just eliminate some of that extra cloud for us so we don't see it. And we'll do a horizontal section as well. Just through this section there. Okay. All right, so again, I'm going to pick the 4th one across. Here we go. And perhaps I'll return this back to wireframe so you can see what's going on. I'm going to reach for the template tools. In this particular case, I'm just going to go by direction and see how well the tool can trace my concrete beams. So I'm going to set my search interval to 3.5, so that'll give us 8 or 9 segments between each of the piers, and give it a chance to follow the curve, that vertical curve that we've noticed already. The sample size, I'm going to go full width of the concrete beam. So let's give this a go now. We're going to start here. 2, 3, 4. I'm going to start this end. And so I've got the width about right. So we're just going to tell it to shoot off this direction. And TopoDOT will process this and will generate trace lines. Let's see how far it got through here. Yeah, it stopped at this point. What we'll do is we'll give it another go, see if we can get it to finish off the full length. Yeah. Stop a bit short again. Probably won't get this last one. Here we go. All right. So the break lines that it's created, it's got these on either side, which is that narrower part of the base of the concrete beam. We're not interested in these now that we've got it placed. We're just going to knock those off. And we're going to take these existing ones and we're going to join them together. You notice that we've got an extra vertex there, so I'm just going to clean that up before we go too much further. So we should only have one left. There we go. We'll join it to this next section as well. Join like for like. Get rid of the extra vertex there. Don't want that, that'll affect the extrusion. And how you treat these end ones is up to you. I'm just going to use the adjust line weight tool. I'm going to pick this. I'm going to have drape turned on and I'm going to drape it to here. See if I can line it up in the center. Perhaps turn the drape off this time and keep the same height and run it right through to the end. Again, you could probably spend a bit more time getting this perfectly right. What happened at this end? we're just going to do the same again down here. I'm going to try and drape the first one. There's not much to drape to. Just go right through to the end there. All right, let's have a quick cross section to see if I haven't ruined the vertical alignment of that. Could be adjusted a little bit. I'm going to do it quick and nasty, just lift this up a tiny bit. Too bad. What's happened at the other end? Too bad. All right, so we've now got that line that's been placed using the template tool, and it's followed the concrete beam as we went through there. Same as before, we're just going to place a profile at the end here. So let's grab a quick cross section straight through the end there. And we're going to place ourselves a concrete beam snapped onto that point, convert it to a shape. And then we're going to extrude that. All right, let's come back to the illustration just so we can see this a bit easier. And we'll spin this around. Okay, all right, let's have a look at what we've got here now. We specified 3.5 meter intervals. You can see that each one of these segments is very evenly spaced and they are following the height of the beam at each individual stage. As I went over the pier, it didn't like it because it was out of the range, so it's actually skipped it, and that's actually helped us. It has failed to give us a vertex there, and it's failed over that point, and it's also skipped that one there as well. So these are looking quite good if you compare them how they fit the cloud. The cloud does look as if it goes through there nicely. You can see that it's got a nice steady even curve as it goes over each of the sections. So the sections over the piers are quite low. You can see there is a doming effect as it goes over that last segment. All right, and if we do a little quick comparison with our original straight extrusions, you'll see that the straight extrusions just simply don't pick up these rises and these deviations in the concrete beam. So it's far superior to those original ones. And if we have a look at the 2A, these 2A ones that we place as the drape line hasn't really followed it exactly. We would need to have done a lot of QA on those to make sure that they did follow those heights exactly. All right, let's do another check here. We'll come back to the top view, and what we're going to do is we're going to take a cross section through this beam. This one here is the most exaggerated doming of the concrete beams. And if we come over here and we begin to compare what we've got. Now this particular gray points here, this is the final beam that we did, which was using the template tools. If we now go and compare that with the original ones that we did in a straight line, you can see the straight line ones are a long way off. So there's definitely a lot of doming happening in here. 63 millimeters of doming, and there is a bend, a little bit bend to the right in this section as well. And finally, we'll compare them against the other ones that were done with the drape line. And again, there is the drape line ones here are quite significantly away from where it was. We would have had to do the QA/QC on each one of those vertices much more detailed to get that right. So TopoDOT has provided us with the ability of doing this in a number of different ways. It has produced the best results from the template tools in this particular case. And more to the point, it's given us a lot of tools for us to be able to QA/QC this and find out which is going to give us the best result.